Welcome to Novinium's Masters of Reliability webinar series. Today's topic, Causes, Consequences, and Protecting Your System from Manhole Events. My name is Chrissy, and I'll be your moderator for today's session. If you have questions at any time during the webinar, please feel free to enter them into the chat window, and we will address them at the end of the presentation. This webinar will be recorded and available afterward on novinium.com. Joining us today is our expert guest speaker, Dr. Mark Newton. Dr. Newton is a leading expert in system reliability and manhole events, as well as the Vice President of Engineering at Novinium. Dr. Newton is a published author and holder of 6 patents. He earned his PhD of Environmental Physiology from the University of Portsmouth. He is a senior member of the American Institute of Aeronautics and Astronautics. Here at Novinium, we partner with utility companies to keep underground power networks operating at peak performance, using the most advanced, capital-efficient methods available. Dr. Newton will touch on this during the session. We've got experts available to discuss event prevention after the webinar, either as part of the Q&A or in another meeting at your convenience. Mark, welcome, and I now turn the presentation over to you.
Morning, Chrissy. Thank you for inviting me today. Over the next 45 minutes, we're going to discuss what are manhole events, why do these events happen, what are the magnitudes and consequences when these events occur, how are individual utilities addressing these events, and some specific solutions for both mitigating the consequences of the events and preventing events from happening at all. So, what is a manhole event? In its simplest term, a manhole event is any visible, abnormal event that occurs in a manhole or vault. However, more specifically, these are categorized into 3 different types of events. The first type of event is smokers. And a smoker, as can be seen here, is an event where you have a relatively minor amount of smoke coming out of a manhole, all the way up to billowing black clouds of smoke that causes possible health hazards and shutting down the streets. The next type of event, larger consequences, happens less regularly, are fires. And as can be seen here, in this particular case, a postal truck parked over a manhole that then had a fire event. The car behind is also on fire, and the helpful residents are trying to put it out from what looks like buckets of water. The most destructive type of event that also, fortunately, occurs least often are explosions. These are catastrophic. One of the interesting things I found when I was doing research for this webinar is there's now a pastime in China that children have worked out if you throw a firecracker into a manhole, you can ignite the methane that's pooled in the bottom of these wastewater manholes and get some quite devastating consequences. You can look up yourself on YouTube and find many incidences of it. Luckily, most of the incidences I saw, all of the children got away scot-free, but I'm sure, unfortunately, that's not going to be the case when you see these kind of devastating events occur. So a group called the Mythbusters, I'm sure most of you know them, have also simulated a manhole event occurring. And what they did is they filled 3 manholes with methane and then studied what happened as you create an explosion in these manholes. And what they see is that you get a hugely destructive force, not only to the manhole structures themselves, but also to the road surfaces around. And we often see this when explosions occur in real life. Also, they analyzed the effects of these events and found it's not actually an explosive ignition. It's more of a very, very quick fire ignition. I believe now it's time for our first poll. does your company or organization have secondary or spot networks?
I'll give everyone just a few seconds to answer this question. Just a few more seconds. And I'll be closing the poll.
It appears that of our participants, roughly 80% of you have spot networks and 20% do not, or secondary networks. The second part of this poll is, has your organization experienced any type of manhole event?
And I'll give everyone just a few more seconds to answer this poll. Just a few more seconds. And I'll be closing the poll.
That's quite surprising. Over 80% say yes, you've experienced events. Now we know what an event is, I'd like to go on and discuss why these events occur. We're particularly focused on electrical events here, and electrical events primarily occur because of the failures in the network due to load changes and overload situations that develop that cause thermal aging of both traditional PIC type networks as well as the more common today polymer type networks, so PVCs and other insulations. These polymers degrade all the time at different rates, and we'll come on to that later. That causes gas generation. This gas is almost always toxic and in many cases explosive or combustible at least. And the gas will sit there and accumulate until an ignition source is encountered, and then you'll end up with one of these types of events occurring. Much of the fundamental research into how these types of events develop has been done by Professor Steve Boggs and many of his students. And on the left-hand side here, you can see that Steve's done a lot of work in artificially aging cables and trying to understand how they break down. Steve had a lot of problems creating the full type of cracks that you often see in traditionally aged cable networks, right up until the point where he introduced saltwater solution. And on the bottom left-hand side, you can see he very quickly then managed to generate a fire by arcing across two different phases. Now, cable insulations break down all the time. However, under these type of fire situations, they break down at a highly accelerated rate. And if these type of fire situations occur in normal atmospheric conditions, then most of the byproducts are water and carbon dioxide. However, and hydrogen. While hydrogen is explosive, it's also highly mobile, very light, and tends to exit manholes, even closed manhole structures, very quickly. However, unfortunately, most of the time, we don't have normal atmospheric conditions. We have a low oxygen condition called an anaerobic environment. And when you get decomposition in this environment, you only get a partial decomposition, and you get a significant amount of carbon monoxide generated. Now, we all know that carbon monoxide is highly toxic to people, but many of us don't realize that carbon monoxide is also highly combustible. And when you reach the lower explosive limit of about 12.5%, carbon monoxide will act just like any other combustible gas, and with oxygen and an ignition source will explode. At the same time as Professor Boggs was doing his work, Professor Bill Black was trying to understand the devastative, the forces produced when an event occurs. And Bill initially worked on some mathematical modeling. On the left-hand side here, you can see one of Bill's models, in which, in this case, he simulated a primary fault occurring, and then that primary fault triggers an ignition of a combustible gas accumulation. You can see the peak force is significantly higher when you get combustion of these gases. And in discussions with Bill and being at conferences with Bill, he often talks about the destructive force of these kind of events as being 1 to 3 sticks of dynamite. Additionally, the work that Bill then went on to do, once he'd finished with his model, was to do some real modeling with EPRE and understand how changing cover design influenced the destructive force of these events. So while non-vented solid covers are often much heavier than the vented covers, what Bill discovered was that when you apply a vented cover, because it allows partial venting of the pressure and gases, the cover only travels about half the distance, therefore a much reduced impact on the environment. And what we know is it only takes 3 psi actually to lift the cover from the manhole. It's not only electrical manholes that experience events, as we saw earlier. In this particular case, it was a telecommunications set of manholes in Hong Kong in 2004. This event occurred, and 14 different manholes simultaneously had an event, dislodging 30 covers. Luckily, nobody was injured. It could have been cable decomposition that caused the event. However, the conclusion was it was interaction with a gas main, and it's thought that the gas main created that event. Also, as we saw earlier, we know wastewater creates significant events from pooling of methane. And I found this event, which is particularly significant not only because it's a much higher order of magnitude in its destructive force than many of these events, it flattened the building, but also due to its proximity to the local nuclear power station. So we now understand what events are and why they happen. I'd now like to spend some time focusing on the magnitude and consequences of what happens when you get these events. These are not new phenomena, and in fact, they go back over 200 years. The earliest recorded event I could find was reported to the UK Parliament in 1823 of an event occurring from the Gas and Light Company in about 1820, so that's 200 years ago. In Chicago in the 1930s, there was a series of events caused mainly in wastewater manholes that dislodged covers and caused injury to people. And in 1941 in Akron, there was a particularly large event where several manholes simultaneously exploded. You can see the consequence of that on the bottom right-hand side. Unfortunately, several people were killed and many were injured. So, how widespread are they? In the US, it's estimated there's approximately 20 million manholes. Globally, it's estimated about 300 million manholes. At least 2 million of these in the US are electrical manholes. And about 400,000 of those are the type we were talking about earlier that have secondary networks. This creates over 2,000 events per year. Of those events, there are about 50 that are of the very highly destructive explosive type that gather that political and media attention. And of course, there's significant costs associated with addressing those events. I've split those into 3 main buckets. The first are the direct costs associated with replacement of infrastructure. The next bucket are the indirect costs associated with overloading neighboring networks, possibly causing additional events, and invoking fines for things like unplanned outages. And the last bucket is the indirect costs, not only associated with political and media attention, but also with lawsuits to people and property damage. We here at Novinium last year ran a study for the IEEE insulated cable conductor group C34. What we were trying to do is get a better understanding of the magnitude of these events today. The first thing we looked at is we split the US into two pieces, both north and south, and we focused primarily for the first part of that survey on the north. And we tried to understand how many secondary networks existed in the US. We found about 100 northern US cities have secondary networks. About 11 Canadian cities have secondary networks. And focusing down on cities with secondary networks, of those, 29 northern US utilities told us they had had events. This averaged to about 1.6 events per 1,000 manholes per year. This excludes one large northeast utility that has many of the events that happen in the US, and that's often about 5 times the national average. Canadian utilities reported about half the number seen in the US, of 0.8 events per 1,000 manholes per year. We here at Novinium try to track as many of these events as possible. So when they're reported in the media, when there's particular press on an event, we try and track those and understand what's happening and where. We've seen 17 of those events tracked to date since December. A selection you can see below, almost all of these events are occurring in the Northeast corridor, and that's why we primarily focused initially on the north part of the US, and they occur between here, New England and Pennsylvania. Now, in doing research for this webinar, I came across this particularly interesting paper related to first responders and how first responders should deal with manhole events. Doug Liebacher here wrote up this piece for Fire Engineering, a great group, and he summarized his proposed protocol for firefighters attending events. He had 5 main points of what you should not do and 2 main points of what you should do when you first are in attendance of the manhole event. First of all, if a manhole event is occurring, definitely do not park or step over manhole covers, even if they're not directly involved with the event. Secondly, never pull covers to relieve pressure or heat. Never attempt to extinguish the fires until the power is off, and then only then if specifically requested to do so by the utility. Cordon off the area and make sure nobody inhales the gas or smoke coming from these events. And the last do not is never enter a manhole until the utility secures it, and even then, only if specifically requested to do so. A couple of do's here is immediately call the utility and set up a unified command post. And secondly, very, very important, because there's carbon monoxide generated in these events, check the adjacent buildings and make sure none of that has been forced into those buildings by the positive pressure generated in the events. And where possible, make sure people are isolated from those dangerous environments. As a sideline, we here at Novinium pride ourselves on having one of the best safety records in the industry. And part of that is always wearing appropriate PPE. And so this piece in Doug's paper really spoke to me. An experienced firefighter, Mark, in New York, was walking by a large SUV while he was attending or addressing an event. At the same time, the manhole under that SUV exploded, lifted it 8 to 10 feet in the air, rotated it through 90 degrees, and dropped it on him. He was then trapped in the passenger compartment until he could be removed by his colleagues, taken to hospital, and all he suffered was 5 superficial stitches. So for us, that miracle condition simply happened because he was wearing the right PPE, and in this case, particularly his hard hat. I'd now like to focus on specific utilities and cities having events and what they're doing to address them. And Con Ed in New York, as we said, probably has the largest safety team dedicated to these types of events. One of its biggest programs is to replace many of its solid covers with vented covers. And attending a conference last year, Con Ed said by 2018 they're hoping to have over 50% of their covers replaced with vented covers. An event in Long Beach, California, caused SCE to be the first utility I know of to actually start tethering their manhole covers to the manholes themselves to prevent them becoming projectiles. Columbus, Ohio experienced an event, and AEP then decided to replace all of their secondary networks when that event took out their main control center for several days. That's the big building on the left. So they now have brand new cabling on all of their secondary networks. An event in Cincinnati, Ohio caused Duke to instigate a program of installing hundreds of locking manholes at approximately $6,500 a cover. Several events prior to the Rio Olympics then encouraged the city to mandate the modernization of 4,000 volts before the Olympics occurred. And as far as we can tell, there were no events during the Olympics. As we discussed earlier, London has a long history of events dating back 200 years. My best data shows about 100 serious incidents since about 2010, and London's instituted a program of inspecting many of its manholes and then sand filling these manholes to mitigate consequences of any significant events. It's time for another quiz. How often does your organization inspect your secondary manholes?
I'll give everyone a few seconds to answer. And just a few more seconds. All right, I'll be closing the poll.
A really good distribution here. Looks like most of you inspect every 5 years, some over 5 years. There's more than I expected inspecting every year. So roughly 10% of the participants here are inspecting their manholes every year. Now I'd like to focus on some specific solutions. And the first part of these solutions are how do we mitigate the consequences when an event occurs? These can be broken down into multiple buckets. And those buckets contain hinged, locking, and vented covers, low mass or destructible covers. I've often heard discussions about duct sealing, but I've found no practicable working solutions so far for being able to do that. But there's several utilities looking at structure fill, and there's other utilities who have their own programs. Specifically focusing right now on locking and pressure relief covers, there are several well-known names. Nina has a product called Swivel Lock, and this product actually latches down to the manhole, and during an event, this lifts, allows the pressure to relieve. It's a patented system, and then drops back into place. It has the additional benefit of also being lockable. EJ has a manhole event mitigation cover that actually lifts on one side. This is hinged. When an event occurs, it lifts on one side, vents the pressure, and then drops back into place without dislodging the cover. Both of these solutions require retrofitting the ring to accept their particular manhole cover. Saint-Gobain Also has a product called Pamrex, which is hinged, and this hopefully mitigates the effects of that cover becoming a projectile. And as we discussed earlier, probably the largest program, Con Ed has 250,000 covers. They have replaced over 100,000 of those solid covers already with their vented cover program. Newer technology, but one that's catching some traction today, is these low impact indestructible covers. These covers don't lift when there's an event. They actually completely disintegrate. That means that hopefully no single large projectile is thrown into the air. Therefore, there's a significant reduction in people and property damage using these solutions. As we saw earlier, several utilities are now using structure fill, and London's actually filling their manholes with sand. An alternative to that, not recommended for electrical utilities, is filling the manhole with water. I've also heard many discussions of hollow fill or even ping pong balls used to try and displace the air and prevent the buildup, significant buildup of those combustible gases. An alternative to sand fill is sandbags, and I've even seen solutions where you foam a manhole in place. As we discussed earlier, there are other utilities that are working on their own solutions, and ComEd has a really interesting GIS database where they assess the risk of each manhole in the network and then focus those resources towards those high-risk manholes. As we said, SCE is the first utility I know who have instigated a program of tethering down their manhole covers to the structure in the vault. And finally, Eversource has a retrofitting program where they're covering existing manhole infrastructure with covers that hopefully prevent further degradation. It's time for another quiz. Poll, my apologies. What action has your utility taken to mitigate the effects of manhole events?
And I will give everyone a few seconds to answer this. Please select all that apply. In just a few more seconds, and then we will close the poll. All right, I will be closing the poll.
That's excellent. Well distributed. There's about 20% looking at locking covers, about 25% looking at vented covers, 17% of you are looking at ventilation, and about 50% have no action at all. So while mitigating the consequence of events is one solution, we also prefer the solution of preventing the events from occurring in the first place. And these can be broken down into multiple buckets. Prevention of events could occur by reducing the ingress of salt water into the manhole, by actively ventilating the manhole, real-time monitoring of manhole conditions. In the future, it's going to be possible to do secondary cable rejuvenation of the type that many utilities have now employed programs for their primary underground residential networks. And as we've seen already, several utilities have either replaced cables or pipe and gas infrastructure to prevent events. I'd like to focus first on the Novinium solution for preventing ingress of salt water into the manholes. And what we've developed here is a cover that has a series of grooves and ridges that diverts the flow of water runoff on the road around the manhole cover instead of allowing it to enter the manhole and vault structure. And what you see here is that with your standard one-year storm, we get about a 99% reduction in the amount of salt water that enters the manhole. On a 5-year storm, so this is a very, very high rainfall storm of about 5.5 inches per hour, we see a 90% reduction of the amount of water that enters the manhole. The active ventilation solution that we've developed couples with that cover and has 4 main components. There's the cover itself, the manifold that joins the cover to the air mover, and the air mover is a set of fans we'll come back to in a minute, and then the duct that extends down into the bottom of the manhole. On the left-hand side, you can see the representation of this, and on the right, you can see an actual working product installed in a manhole. We have some really technical boffins here that work at Novitium, and they spend much time working on modeling manhole flow setups. They try to understand not only individual manholes, but how these manholes interconnect together. The system we have developed, we believe, is most efficient for removing combustible gases out of the manhole. It's unique in that the inlet to the manhole, the inlet is around the outside of the cover, and the outlet then circulates the fresh air around the vault and then draws it up through the center of the cover. One particular benefit of this system is it creates a negative pressure inside the manhole. That means you're actually drawing air through the conduits, and more importantly, that carbon monoxide that's generated in the conduits is not allowed to enter buildings. So you're generating that negative pressure that keeps that carbon monoxide out of building structures. These boffins also love to develop unique technology. And one of the points of technology that I'm very happy to tell you about today is we've developed a system by where this venting system is fully submersible. A bell design will prevent any water ingress to the fans themselves. As soon as the water reaches the fans will shut off. The manhole can completely flood. As soon as it comes back down below the fans will re-engage and start drying out that manhole. We have built the system to be fully redundant, so has multiple fans, and any one can fail, you still have full performance. It's designed for 10 years maintenance-free operation. And most importantly, it's very quick and easy to install. It takes about 2 hours with normal hand tools, and a trained technician can install it very easily. Just as importantly, when it comes time to service or enter that manhole, it simply removes the cover in the standard way, pull out the central venting system, disconnect the electrical connection, and with a pull of a single pin, you can then remove all evidence of that manhole venting system from the manhole. To complement this, we've also developed a real-time monitoring system. This allows continuous monitoring of the conditions within the manhole. It provides feedback on the performance of the ventilation unit, but it can also be used autonomously without the ventilation unit. It can be used in a standard SCADA type network, or it can be used in remote or populated areas where SCADA is not available, and we have an encrypted cell uplink that allows access to that real-time data. There's many configurations available, but our standard configuration comes with multiple gases, including carbon monoxide, oxygen concentration, VOCs, as well as things like methane. You can measure temperatures and airflows, as well as humidity, because the ventilating system also significantly accelerates drying of that manhole and improves manhole health. Lastly, we can also look at water level within the manhole structure. The same boffins here worked on a bell housing for this design, so that this can be completely submerged for long periods of time. When the water level raises above the data logger automatically shuts off. As soon as the water level drops below that data logger, it comes out of standby mode and starts retransmitting data about the state of the manhole. When this is coupled with our real-time data analytics and analysis system, it becomes a very powerful tool. It allows you to understand the state of any one of those loggers in your network. You can drill down into a single logger, and within that single logger, you can then see the unique values here: temperature, the gas concentrations, the water level, the humidity. Importantly as well, this type of system allows you to have an individual characterization for that manhole and set normal operating limits. The additional benefit as well is using GIS type technology. If you've got multiple issues and multiple manholes, you can understand the relationship of those in your network. And as I said earlier, you can define limits, you can look at individual values, you can look at historic data, but when any one of those limits is breached, you get an immediate notification, either to a cell phone or to your control center saying, hey, manhole 76 is having an issue, please go back and look at that manhole. So, in summary, manhole events are a growing problem, not only in the US, but also for international utilities. It's estimated that over 2,000 events occur in the US, and that number is increasing, and over 10,000 events occur globally every year. The consequences of these events are increasingly attracting political and media attention. Mitigating the consequences of these events does reduce the damage, but also requires us to deal with system failure. And prevention solutions are now available from Novenium. If you're interested in learning more, there's many great resources available for these type of manhole events. One of my favorites is the IEEE PES C34 writing group. They're focused on trying to compile as much data as possible around why and how these events are occurring, as well as possible solutions to these events. The Jody Lane Conference is sponsored by Con Ed, and is not only a great source for manhole events, but also for mitigating stray voltages. The Electrical Network Systems Conference also has several presentations related to these events, as does the EPRE conference. One of the best journals from IEEE is on power delivery, and there's many articles in there related to manhole events. I spent a significant amount of time trying to find resources outside of the electrical industry, and the only one I could find was the Oil and Gas Safety Conference and Exhibition. Also, we have a database of historical events, why events occur, and more information available at Novenium. Thank you very much for your time, and I'll now take any questions you have.
Thank you, Dr. Newton. We have received some questions from our audience. The first one is, when a secondary cable starts to break down, is this a fast or slow process?
That very much depends on the situation in which the cable is breaking down. As I explained earlier, under fire conditions or under saltwater conditions, cables break down at a much higher accelerated rate. Therefore, especially under fire conditions, these type of events can generate enough gas to cause explosions very quickly. Under normal conditions, it can take months and months and months for these events to accumulate enough gas. And even when that gas is there, it stays there accumulated until an ignition source is available. And then you get the type of catastrophic event that we've been discussing.
Thank you, Dr. Newton. The next question asks, can I get a copy of this presentation?
Yes, this presentation will be available after this webinar on the Novenium website.
Thank you, Dr. Newton. The next question is, how heavy is the ventilator unit for removal?
The ventilator unit itself, once you pull off a standard manhole cover, is about 40 pounds. It can be easily pulled off with one person. No lifting equipment is required.
Thank you. Our next question is, what sensors does the data logger include?
So typically the data logger includes temperature, airflow, and we can measure either airflow through individual ducts or around the manhole. relative humidity to understand the drying conditions in that manhole, four different gases, which is carbon monoxide, oxygen, VOC, and we also have a CO2 sensor, and water level. So understand how much water is currently in the manhole.
All right, thank you. We have one more question, and this one comes from Lee, and he asks, what is a boffin?
Apologize. A boffin is an English term for one of those technical geeks, I believe that you call them in the US. They're the guys who love to be back in the lab, tinkering and making new technology.
All right. Thank you, Dr. Newton. I believe that concludes our Q&A session for today. Thank you so much for taking the time to speak with us today, and thanks to everyone for joining us. If we were unable to answer any of your questions today, we'll make sure to reach out to you after the webinar. To find more information and case studies regarding cable infrastructure programs, please visit our website, novinium.com. We hope you enjoyed the presentation, and please take time to complete the survey at the end. We look forward to Novinium's next Masters of Reliability webinar. Thank you.